My name is Atul. This is my colleague Adam, and we're really excited to have you here today so we can talk to you about how we're building intelligent applications and enabling experimental machine learning with Uber's data science workbench. So a quick overview of what I'm going to be talking to you today. We'll go over what makes data such an exciting and challenging place to be at Uber. I'll then walk you through sort of our data analytics stack so you have an understanding of why the scale and scope is so large and why we need to help teams with tools to make sense of this and understand this better. I'll then talk to you a little bit about machine learning at Uber and why it's so foundational to pretty much everything that we do at the company. Adam will then come on stage and talk to you about Data Science Workbench, which is the tool that we've built to help teams make sense of this and be more productive. And then we'll go over some real-world impact to show you what impact this tool has had on teams at Uber and on the product itself. So with that, let's get started. My name is Atul, like I said. I was an engineer before this. I built games at Zynga, games like Farmville and Words with Friends, as well as the mobile advertising platform. So if you've ever played those games or clicked on an ad, you've interacted with some of my work. I now work at Uber as a product manager, where I'm managing the Data Science Workbench, as well as Uber's data warehouse. So let's actually dive into what makes the data world at Uber so challenging and exciting, and why we actually need all of the tools and technologies that we do to make sense of this. So Uber's mission, as you may be aware, is to bring reliable transportation to everyone, everywhere. And we use data to do this. Data informs every single decision that we take at the company. Our data is vast, and it holds a lot of deep hidden insights. So the job of my team is to actually surface these insights to the people that care about them the most. These people, over 6,000 data scientists, engineers, product managers, operations managers, all over the world, they rely on us. They rely on the tools, on the technologies, and on the services that we provide to support the business every single day. So data is actually what differentiates Uber. But data at Uber also is very different from anything that you've seen anywhere else in the world. And there are a couple of different reasons for this. So let's actually go through those, right? So there are several things that make Uber as well as our data very unique. And one is just the nature of our business. So we're a pluggable mobility platform that is a delicate marketplace with network effects all over the world. And it's actually moving bits to atoms. So when you press a button on your app or on the web, we're actually moving physical things in the real world, right? So we're moving cars, we're moving people, we're moving food from restaurants, we're moving trucks, we're moving bikes. And the fact that I mentioned bikes, we're also launching these new lines of businesses in an instant. So a few months ago, we acquired Jump, which is the bicycle sharing company. And instantly now, our data platform has to evolve and adapt to the fact that we now have bicycles on the platform as well. So it's not just trucks and flying cars and self-driving cars, but also things like this. So we have to adapt to these things. Our analytics then also become very unique, right? So they're real-time, real-world, and they affect things in space and time. So every query that you run is actually changing things in the physical world. The sheer scale of this is also fairly unimaginable, right? So we have our operations in over 600 cities, 65+ countries, growing all the time. And so to make sense of all of this is humanly not possible, which is why we're using machine learning in every single aspect of our business to make sense of the world and to actually continue making these experiences magical. And then it's the people that are actually making these things happen. So we have over 6,000 engineers, scientists, operations managers, product managers all over the world who are using these tools every single day to do their job. These tools are also receiving queries from apps and machines as well. So we have self-driving cars on our platform. We have intelligent tools that are firing off queries all the time. The people who are using these tools also have a very wide spectrum of skills and experience levels, right? So some of them are doing business intelligence and writing ad hoc queries. Others, like data scientists, they're building deep neural networks. And they're all using the same platform, the same tools, the same technologies, and interacting with the same data sets. So these are just the internal customers, though. We also have external customers that we need to worry about. So if you may have heard of the product Uber Movement, that's the product that we're using to share data with city governments about city traffic and traffic patterns and things like that. Now, those customers also are interacting, again, with the same data and the same tools. So we really have to adapt to all of these things. And that's kind of what makes data at Uber such a challenging place to be. Which then makes my team's job actually really exciting, right? Our mission literally is to move the world with global data, local insights, and help them combine these to make intelligent decisions. To do this, before we get to do this, oh, I'm sorry, we can go back and take that. But to actually do this, there's a lot of different pieces of the puzzle that you need to kind of understand before we go into how data science Workbench is helping solve these problems, right? So let me give you a quick overview of the data analytics stack as it exists at Uber today. The data team is broadly split into two divisions, right? So we have the data infrastructure side of the house and the data platform side of the business. So data infrastructure, fairly self-explanatory. This is the team that actually, or teams, that actually manage all of the tools and services and technologies required to produce data, ingest data, model data, store data, disperse this data, and also manage all of the workflows that are required to make these things happen. And on the other side, we have the data platform side of the business. And they're building tools and services that rely on this foundational infrastructure. So they're doing things like business intelligence software, visualization tools, ad hoc or streaming analytics products, machine learning platforms, a knowledge platform to make sense of all of this data that exists, and our experimentation and segmentation platform so that all of the cool things that we build can be rolled out seamlessly to customers without sort of affecting them on a day-to-day basis. So now that you kind of have a sense of how the house looks and how it's divided and how the teams are doing all of these different things, let me actually walk you through the infrastructure stack itself. So you get a sense of the complication that's involved for users who are interacting with this every single day and for teams that are building software to help teams do this better, right? So we'll start at the very beginning because this is a pretty expansive stack. And at the very beginning, we have our data that's coming into the platform. So this could be through Kafka streams, through schemaless, SOA systems. And this is all of the data that comes in from various data sources. So it could be from the Uber app. It could be from the rider app, the driver app. It could be from the freight app, the Uber Eats app, our restaurant manager app. We have various different applications that are feeding data in. But it could also be third-party data. So for example, it could be weather data that we're pulling to help predict traffic patterns and price rides better. It could be traffic data that we're getting from cities. It could be map data that we're getting from our map providers to make our mapping platforms better. So all of this data comes in, there's a very large volume of this coming in all the time. It's intercepted by our streaming and real-time systems. So we use Athena X or Apollo for streaming and real-time. And various teams use this platform to determine decisions that require a sub 5-minute latency, for example. So one example here is the pricing team. For example, they're trying to determine the right price for every ride in every market all over the world. And if you're the rider and you're on your app waiting for a ride, you really don't want to wait for more than 2 minutes to get moving. So they need to make these decisions really, really quickly. But not all teams need that speed. So all of this data then lands in our data lake, which is Hadoop. And this could be raw data. It could be raw tables. And then we have a team that actually models these tables to make model tables out of them and make sure that these are actually more useful and more effective for querying and for other business purposes. We have Hive, Presto, and Spark that actually interact with all of this data. And then the final piece of the puzzle is actually Uber's data warehouse. So this is where data lands after its long journey from ingestion to for sort of completion. And our warehouse actually holds some raw tables and all of our model tables. Various parts of the stack are optimized for various needs, right? So I told you about the streaming and real-time systems that are for real-time use cases. Our warehouse is, on the other hand, optimized for query latencies, for ad hoc querying and interactive querying, and also for speed and simplicity of use. So we have various operations managers all over the world who are relying on this every single day to do their job. So now if you have infrastructure of this size and scope, it's very natural that there are other challenges that we're trying to solve. So we have things like security. In the GDPR world, we want to make sure that our data is secure and not being used by bad actors. We have to be all active, which is we have multiple data centers, and we want to make sure that if one data center goes down, we're able to seamlessly switch to another one without sort of impacting our business. And then we, of course, have things like observability and cluster management, where cluster operators are using this to determine exactly what's going on in every part of our data stack to make sure that things can be resolved really quickly. And then if you remember from my previous slide, this is where the data platform side of the business comes in. So they're interacting with all of this foundational infrastructure to do things like experimentation, machine learning, building our apps itself, some ad hoc querying, our notebook service. So all of these various applications, some of which I haven't even been able to capture on this slide, are all relying on this vast foundational infrastructure. So a couple of times here, I've already said machine learning is pretty foundational to what we do at Uber, and it really is. So I want to actually show you what I mean by that and how we're infusing it into every single aspect of the Uber journey. So let's first begin with what the hype is, right? So quite simply, machine learning is the ability of your machine to learn without being explicitly programmed. It's the ability for it to identify hidden patterns based on current data, based on historical data, and use it to actually predict the future. And then finally, as the word learning may suggest, it's the ability of this machine to get better at its task, to learn from its mistakes, and to get better given more data and more experience. So quite simply, this is exactly what machine learning is. And if you think about what Uber is doing and the challenges that we're solving, this is exactly what we want to do. We want to be able to find hidden patterns in all of the vast data that we collect and then surface it to the right teams at the right time to help them make decisions that can move us forward. So like I mentioned, it's foundational. Well, let's actually go through what happens in an Uber trip and see exactly why what I'm saying is true. So I love the future, and I love a future where we have a self-driving car picking people up. So that's what I kind of modeled this on. So let's assume there's a self-driving car. Mike is here at the movie theater, and he's just ordered an Uber that's come to pick him up. But let's step back and think, how did that actually happen? I mean, how do we do that magic, right, where you press a button and a car shows up? Well, we actually use machine learning for some parts of that. So things like demand prediction, figuring out where we want to have our supply at the right time, at the right place, so that we can fulfill every ride request in under whatever 2 minutes that people really expect. So in this case, we're positioning cars close enough to a movie theater because we know there's going to be a certain amount of demand in that area at that time. Now, it's a self-driving car, so it needs to get there on its own. So it needs to do things like object detection, motion planning, route planning, et cetera. And I'm guessing some of you have heard of Uberpool, if not ridden an Uberpool itself. In that world, we're also doing things like pickup clustering to make sure that we're picking up people in the right order at the right time so that no one's waiting for too long, either off-trip or on-trip. So now Mike's been picked up. He's sitting in the car. Remember, there's no driver, so he needs to be able to tell the person how to get where they want to go. In this case, he wants to go to a Mexican restaurant. So we're doing things like voice recognition to figure out exactly where the car needs to go, where the passenger needs to go. And safety is, again, a major priority for the company, so we're doing things like supply modeling and occupancy modeling to figure out who's in the car, where are they sitting, and other characteristics to determine how safe we can make this ride. So now we're in the ride. The car knows where the rider wants to go. Now comes the exciting part, right, which is actually planning the route. So figuring out what the route is, figuring out the ETAs, actually doing some road classification. So what we're doing is gathering data to see if roads are bad, and then feeding that into our system to make sure other cars are not routed in the same way, and things like that. So again, these teams are using machine learning to power those algorithms and figure these things out more intelligently. The slide in the middle is another very interesting use case. So Mike's sitting in the car, and he's gotten this notification that says, hey, are you willing to pick up others for a discount? And in this case, he said yes, because who doesn't like a cheaper ride? But that's, again, a very interesting application. So we're doing elasticity estimation to see what is the propensity of this rider to be willing to trade off some time in exchange for a cheaper ride. Now, we can't just offer this as an option. We also need to make sure there's actually demand. There's actually somebody we can pick up. So we're doing some demand prediction there to see, is it worth actually making this offer? Now, once Mike has accepted the offer, we need to do the whole route planning and ETA estimation once again for the rider itself and for the new passengers that we're picking up. So now we've done that. We're on our way. We're picking up these passengers, and he's getting dropped off at a taqueria. Of course, like humans, we forget things. I'm guilty of this very often, and it looks like Mike is too. He's forgotten something in the car. So we're doing things like speed generation so the car can actually talk to you or send out relevant messages saying, hey, you seem to have forgotten something in the back seat, and do you want to pick it up? And we're also doing things like drop-off clustering in this example, where we have multiple passengers in the car, and we want to try and drop them off in the correct order. So if you've ever taken a trip where you have some passengers who are Uber Pool riders and others who are Express Pool, which is our wait a little, walk a little product, we want to make sure that we're dropping you off in the right place so you don't have to waste too much time either walking or waste too much time on trip. So all of these are, and this is a very small subset, of course, but these are all examples of how teams are using machine learning in various parts of their workflows to optimize their process to make sure that every ride still remains magical. So with that, you now have a sense of why I keep saying it's so foundational. So let me walk you through what a typical ML workflow sort of looks like for all of these teams, right? So 4 very basic stages that are going on here. So there's the there's the definition stage, the prototyping stage, there's the productionization stage, and finally the measurement stage. Now, again, this is a process we keep going iteratively around this. So in the definition stage, what happens is customers and cross-functional teams are sitting together. They're trying to define the objectives and the KPIs that they want out of this product. It's very data-driven. A lot of research is required, and they prioritize exactly what the MVP needs to look like. Now, once that's done, we go into the prototyping stage, right? So here we're gathering data with SQL or Spark from our various data sources. It could be data that we don't have right now, so we need to kind of update our mobile apps to gather some of that data, for example. We then go into the data prep stage where we're cleaning this data, preparing it in various ways to make it more usable, more friendly to whatever the next step in the process is. And we actually build the model now and train it. So it could be trained using CPUs, or if you want deep neural networks, maybe do it with a GPU. And evaluate this for validity, complexity, et cetera, to make sure that you actually have a prototype that serves your use case as well. Now, once you have that, you actually want to productionize it, right? So this is where your engineers and data scientists sit together. They write code to productionize this model, translate it into whatever language is supported and necessary. They deploy this model using various ways. And this involves using our experimentation strategy to make sure the rollout is smooth and seamless. And they finally use this to actually make predictions. So these could be real time. So in the case of that example that I showed you where we're trying to see if this rider is willing to pick up more passengers, that could be a real-time decision, right? Or it could be a batch prediction where we're predicting things given past week's data to figure out what the next week's world looks like. Now, once we have this model out in production, we actually need to measure and monitor it. So this is the final stage in the process where we're monitoring these predictions to automatically detect regressions, to detect degradations, to make sure that we can make changes to the model, retrain it if required, and finally feed all of the analysis, the data that we're getting out of this, into analyses that will drive the product roadmap so that we can continue making our product better. And again, this is a cycle. So we get some data, we figure out what's going on, go and redefine the problem, remake the prototype, et cetera, and keeps going on and on and on. So it's a continuous process, continuous workflow, but this is sort of the most simplistic example that we get of a typical ML workflow. So far I've given you a good sense of, or at least I feel like I've given you a good sense of the scope of data at Uber, why it is an exciting place to be. We've spoken a little bit about the infrastructure itself, so the various technology pieces that teams need to deal with every single day to kind of make magic happen. And I've given you a primer on how machine learning is, again, very foundational to what these teams do and how they're using it in more and more ways every single day. So to make all of this simpler for our teams, to make their workflows more efficient and make them more productive overall, we're going to talk now about the data science workbench. So I'm going to hand it over to Adam to take you on this part of the journey. Thank you.
Thanks, Atul. So next, there we go. So yes, my name is Adam Hudson. I'm a senior software engineer at Uber, and in previous lives, I've worked with big data and big network research and development in video gaming, social media, and finance, and also at universities. And I'm currently a developer on the data science workbench. So in 2016, Uber's data science community was growing rapidly, and everybody was doing their own things, and they were starting to run into a whole bunch of problems. So most teams had DIY solutions, which were running directly on laptops, and they had to work out their own ways to get access to the data they were using, and that meant there was a whole proliferation of tools and libraries and data connectors. And sharing and collaboration was basically non-existent. So all of these factors together meant that the simulation environments being used by the community weren't terribly scalable. They mapped poorly onto production environments, and they weren't offering the features that were actually required, like compliance and security and data center redundancy. The data team recognized that there was a challenge here that needed to be solved, as this area was going to be the next growth area for Uber. So we set out on a mission that we had to solve, which was to unleash the productivity of Uber's data science community. So this is not a new problem. Many other companies have tried to solve this in the past, and there were multiple solutions out there already. And they offered great functionality, but none of them were quite flexible enough to suit our range of users that we had and to serve the specific needs that they had. So you can see quite a few different ones. So our diverse customers that I mentioned, they include highly trained data scientists who are building and running complex mathematical models. We have developers and interns who are doing more casual analysis and also building dashboards for others to use. And then we have the people who are using the dashboards, which are like ops staff in Greenlight hubs and that sort of thing, or Eats ops staff, and external parties as well who may want to use them. So as Atul previously outlined, the range of data sources and computation resources available to our employees are quite vast as well. And so we wanted to make sure we had smooth integration with all of them and with restrictions based upon the account permissions that belong to them. In short, we wanted a unified solution that allowed everybody to work with all the same data, work together, and not cost us a fortune to set it up, which is where the data science workbench was born. So this is a rough overview of what it is, and I believe if you want this in more detail, our blog post actually has this picture as well. So it's a browser-based tool that gives users access to advanced computing capabilities using their favorite language and IDE. The first row up here shows that it offers all the features you would expect from a product like this, so sessions and files and schedule jobs and the like. The second row, though, is why people love us. They can spin up a new session on demand, and it runs in an isolated Docker container that belongs entirely to them, and it has full access to all of their persistent files. It has the environment that they want with customizable memory and processing capabilities, and they can install whatever package they want to without any admin assistance and without any risk of interfering with the environments of other people. They can run multiple notebooks or programs in the same session to do different tasks, or if they want to, they can spin up different sessions to do different tasks. If they have more complicated requirements that they can't get out of the box, they can talk to the data science workbench team, and we can help them set up a customized environment and deploy it to their environment directly for them. Because these sessions are server-based as well, rather than on laptops, it makes them perfect for serving dashboards. So we support Python, Bokeh, and Shiny dashboards, and people are using them quite widely. Finally, the third row here shows how the environments have access to the full suite of large-scale processing that Atul outlined before. And yeah, quite a lot of them. And basically, together, people just love the fact that they can do everything they need to, all from the same application, without having to shift between tools or modalities or whatever. It's just like, it's all there, and it does what they want. So, with this solution in place, you can see how we've started to address many of those problems that people were facing back in 2016. There's no barrier to entry. They just go visit the site, then they just start working. We provide everybody with a predictable, known good environment, which is standardized currently around Python and R, and that comes with a wide range of capabilities they need to do everything they need. We ensure that all the libraries and the networking and the accounts are available to access everything that they need at Uber. We also provide a wide range of session sizes and CPU and memory and that sort of thing, including GPU nowadays. And because it's all coming from the same service, rather than running on laptops, it becomes really easy for people to share content and collaborate and to work immediately with that content and to publish dashboards that are based upon it. And also, because it's a common environment, it makes it much easier for my team to document what's available and to support people who run into problems. So the DSW service is being used in a variety of different ways. Atul's going to go through them in a bit more detail later on, but I'll just go through some of the quick use cases that, common use cases that people are using. So users might need to do large-scale data exploration and identify trends, machine learning, feature generation and model training. They're kind of just day-to-day ad hoc data analysis and prototyping that data scientists do, and collaboration in a variety of ways. So reviewing each other's code, sharing useful snippets in notebooks, and producing dashboards to expose their findings to help others do their work. And I'll point out also that the feedback and customer satisfaction surveys we've received have shown that people, yes, they really are benefiting from what we're doing and it's helping them do their work better. So I'll now just give a brief product walkthrough so you can get an idea of what this actually looks like in practice. So a user visiting the site is presented with this. So at the moment, you can see this person currently has 2 sessions running, one in RStudio and one in Jupyter. But if they didn't, they would click on the Create New button and it would present them with a pop-up. And from that, they would choose whether they wanted a Jupyter or an RStudio session. They would choose what CPU and memory requirements they had. And as I said, that includes GPU nowadays as well. And they would click Start. And it takes a couple of minutes to get the container set up on the appropriate machine and up and running and whatever, and so they'd see it there in the pending state, and eventually it'll go to running, and then that's great. So they can click on that, and then they can view on the right-hand side there what that environment looks like, that session looks like. So they can see name, they can see the kernels are installed, they can dig a bit deeper into that to see what packages are available on those kernels. If they scroll down, which doesn't show up here unfortunately, they can see the recent memory and CPU usage of those sessions, and then most importantly, they can click on Open Session to actually start doing work. So this is a Jupyter session, which the resolution is horrible for, but you get the idea, which looks exactly as it would if you were running Jupyter on a laptop. All the files from their persistent storage are here and ready to go and work with any of the kernels that are available. And there are a range of kernels, so I don't know if you can really see that there, but there's PySpark, there's Python 2, Python 3.4, R, and Scala. And just, it's really easy to work with any of them or even to add new kernels. So just a couple of weeks ago, I helped somebody get a Python 3.6 kernel set up in their environment and worked great. And so now I've folded that back into the standard environment that people get out of the box. Or you may wish to work in RStudio, and again, that looks terrible, the resolution. You may wish to work in RStudio, which looks like pretty standard as you would expect RStudio to look. And this person here is currently developing a dashboard, so that says Shiny Server up the top there. And they basically can test it in this environment, and then when they're happy with it, that they can publish it, which we'll get to in a minute. And you can also view all the persistent files that you have through the sharing interface. And from here, you can specify any shares you'd like to share, any files you'd like to share with others. You can copy and share the link between people, or you can browse through the list of files that others have shared themselves. And when you find a file that you like, you can choose to clone it directly into your own file space so that you can then just start working with it straight away. And so this is the interface to our scheduled task functionality. So users are effectively specifying a Linux cron job here, and it runs on a scheduled basis on one of their existing sessions that they set up previously. It's obviously really useful for our users because they can get the environment working interactively within their session. Once they're happy that all the packages and all the programs and everything are working fine, they can then take advantage of the always-on capability of the session to run the tasks at irregular hours. So common tasks that people are using this for include daily batch jobs to update dashboards. They're doing retraining of machine learning models, and they're running batch prediction to evaluate these models. DSW does support rich dashboards, as I mentioned a couple of times, written in Python Bokeh or Shiny, and they're each running in their own session again. So again, they can set up their own packages. They can make it all just right by experimenting with it in RStudio or in the Python Jupyter notebook, and yeah, until they get it right. And so this here shows a dashboard that was built on Uber's recently open sourced Viz package, Kepler, and that looks pretty cool, I think. But this is the browsing interface, so you can see all the ones that other people have published in the past, and you can have a look through and see what they all look like. So again, a bit more of that sharing is going on there. But then those share and share with X links, you can actually go straight to see it full screen and interact with it. And the share with X is something we do quite often for people like restaurants and that sort of thing. They can view dashboards, even though they're not part of Uber itself. So we've done a lot with the data science workbench, but as you'd expect, there's a whole bunch more we still actually want to do. And so we've obviously got lots of plans, but this is stuff we're actually working on right now. So this is not long distant future. This is actually going to be available quite soon for our users. So our standard environments are a great starting point, but many teams find that when they create a session, the first thing they do is they run a bunch of packages to install, a bunch of scripts to install the packages they need, or they may want to install different software, so we've had people who wanted Jupyter Lab, that sort of thing. So rather than having to repeat that workflow, we wanted to make it easy. So we're helping to get it so that they can set up these environments and then capture that, so that next time they create a session, they can just say, work from this snapshot that we set up. And they're instantly ready to start working, without having to do sort of setup steps or, document how to do it or anything like that. We're creating a YouTube-like sharing interface so that basically people can create content or they can source it from the wider internet and they can publish it for others to explore. And then from that interface, we'll make use of views and likes and tags and that sort of thing to make it so that the best content can be explored once people have shared it. Where moving experimental models directly to production has been a large pain point for data scientists in the past, and so we want to make it easier, as all of DSW is trying to do. So we want to help them integrate their local work better with the larger machine learning infrastructure available at Uber in a one-click manner. And we're also in the process of getting all the libraries and all the GPU infrastructure necessary to support distributed deep learning on our platform. And with that, I'll pass you back to Atul to go through some of the stuff that DSW has really made a difference to with our community.
All right, thanks, Adam. I hope you guys got a good sense of what this product looks like and why it was kind of built to help teams make sense of the vast infrastructure and challenges that the company has from a data perspective to actually make a difference. But as promised, I wanted to share some insights about the impact that's actually happened in the real world that some of you may have even seen in your Uber experiences that has all actually been built using Data Science Workbench over the past year. So this is just a quick overview of some of these use cases. We have a lot more, but let's actually go through some of these, right? So safety, as you may have heard, is the #1 priority for Uber now, and we want to make sure this is the safest ride that you can take anywhere in the world. And so for this, the safety team is actually building models using Data Science Workbench to do things like trip classification. And so what this means is they're actually gathering data from every single trip to make sure that this trip is happening in a safe way, drivers are driving properly, and things like that. I'm guessing some of you have used Uber Eats, but for the few that have not, this is our food delivery app where you can pick a restaurant and the food is magically delivered to you. What this team is actually doing is something pretty challenging as well, and that's restaurant recommendations. So even in the real world, it's kind of hard to recommend a restaurant to a friend and make sure that this is actually something that they're going to like and enjoy. But imagine doing that on a cold start on a mobile app that you've just installed. So imagine the scenario, you've just downloaded this app from the App Store, and we want to make sure that your first experience is magical, which means we have to present to you a list of restaurants that you will possibly like and that you will possibly click through and order. And so that's what this team is doing. They're gathering all sorts of data that they can get and building these intelligent models that will allow them to present just the perfect list of restaurants for your first-time experience on Uber Eats. Now, Uber, as you can imagine, has driver partners on the platform, and we need a lot of driver partners to make sure that we can serve every single ride in sub 5-minute ETAs or whatever the expectation is. And so in this case, we want more drivers to drive for the platform. But that also increases the chances of risk and fraud, right? So the risk team is actually using models built on DSW to make sure that the right driver is driving the car at any given point of time. We're also encouraging drivers to refer their partners. And so they're doing things like referral risk scoring to make sure that there's no fraudulent behavior going on here when drivers are recommending other people to drive for the platform. Now, Uber, as you can imagine, has a very large operational footprint. We're in 600 cities, 65 countries, which means we actually need boots on the ground to manage sort of the network effects that are going on. So we have green light hubs, and we have other operations offices. And what these people are doing is they're using our data with these models that they've built to actually do some lifetime value model calculation. And so what this means is they're trying to determine the lifetime value for every single stakeholder. So this could be a rider, it could be a driver partner, it could be a restaurant owner, it could be a restaurant courier, it could be a truck driver, I don't know, and any other new business that we kind of spin up. And they're trying to determine what the LTV for this customer is so that we can accurately target incentives at the right time and the right amount to make sure that we're driving maximum value for Uber and for the customer itself. And then finally, support. So as you can imagine, for an operation that's this large, support is a very large cost center for us and a very important part of the experience. So the customer obsession team that is trying to make even the support experience magical, they're actually using this to build NLP models for support tickets. So what they're doing is they're using these models to help our agents accurately answer questions quickly, help direct queries automatically to the right center, and also actually help you answer queries automatically in the app. So if you notice, a lot of our support interaction points in the mobile app itself, they're sort of like you click a button and you report an issue, and the issue is actually resolved right then because we're circumventing human interaction altogether and just solving it based on data that we've gathered before and experience that we've had in the past. So these are just, again, a very small subset, but some that I thought were particularly exciting to talk about because these are likely things that you've definitely experienced if you've ordered from Uber Eats, taken an Uber ride, driven for Uber, et cetera, or filed a support ticket, which I hope there aren't too many. But with that, I think there's one more thing that I wanted to talk about. Obviously, the challenges that we're facing are intense, and it's a very exciting place to be where we're building all of these cool things and actually moving things around the world. And so we need people to help us do this. So if you're excited to build sort of the data platform that actually moves the world, come join us. We're looking for people in San Francisco, Palo Alto, Seattle, and Bangalore. So if you're in any one of those cities or want to move to one of those cities, please look at that link, and we'll be happy to have you. With that, we have some time for questions. So can you come up, and we'll go through that. Go ahead.
So my question's about, so I saw that you mentioned that you have the model deployment in that circle.
Yep.
So I saw that the data science workbench seems to have some really good integration for the actual model development. But when you actually want to take that model from development and into production, you briefly mentioned something about, working with the DevOps engineers to actually write some code either in Java, I don't remember exactly the languages. So is that how the process would work in Uber, that every time a model is developed, then they have to go through and go through a different deployment strategy, or is there some sort of automated deployment?
Absolutely. So great question. In the past, that was exactly how it was. So each team would come up with their models and then figure out how they want to deploy it. So they would go and find some engineers, and, get them together, find some infrastructure somewhere, cobble it all together, and then have the support cost to build it. So now Uber actually has a platform for this called Michelangelo. This is our production machine learning platform. Okay. And they actually work with that platform to build it. But with DSW, this is currently something that we're building right now. It's in beta and will be live right now, where you can literally build your model, you prototype your model in DSW and hit a button. It actually goes and finds the infrastructure, scales it up to whatever your QPS is going to be, and gives you a REST endpoint. So you can put that endpoint in your mobile app, in your internal app, in a dashboard, wherever you want it to be, and it can actually serve traffic. So that one-click deployment is actually in the process right now. Right now, it's a few more clicks than that, but that's how we do it. We don't expect each team to now spin up their own infra stack and have their own team built around it.
And in particular, not have to redevelop it. You've already done all the work of developing it. You know it works. That's it. Good. You want to start working with it as soon as you can.
Yeah. So, yeah.
Thank you.
One quick question. So do you guys use any of the external cloud vendor providers like Amazon, Google, or it's all internal? Uber has built all these internal?
So Uber has a variety of data sources, right? So like as you saw on that slide, a lot of it does live on Uber's own cloud. There are some teams that do use AWS for some of their use cases. We have experiments going on with GCP, Azure, whatever. So it's all over the place. And with DSW, what we're doing is we're making sure that we're building connectors to all of these platforms. Right now, we have whatever data sources that are currently available. Sorry.
I don't know if I can actually go back to there.
Oh, I can do that.
Yeah, okay. I was going to show that, yes, there was that bottom row. So at the moment, we're not heavily working with S3 or that sort of thing, but some teams do have things that use it. So I was looking for the red slide. Yep. Nearly there. Sorry. That one, right? Yep. So basically, because of the nature of it, there's no reason why we couldn't just integrate the extra connectors as part of the standard environment for people to start accessing what they need to. And in terms of where it's actually running, as Atul said, it's the instances, the sessions are actually running in our own cloud environment, but there's no reason why, if we want to grow into that sort of space, that we couldn't, when we spin them up into S3 instead.
Got it. Yeah. One another question. On the data, do you guys also have something like a data marketplace kind of a thing? Because when you do all this analysis, right, you will also have to marry with external data sets as well. So do you have a partnership with several of the other partners to get ingest data into your platform?
I mean, yes, we do have partnerships with companies where we're getting data. So like I mentioned before, we're doing things like weather data, traffic data, map data, and various other external data. What happens is all of that data actually comes and lands in a few more clicks. It actually comes and lands in our data infrastructure, right? So it's going to be somewhere here. That data, the input data could be in any of those on the left side, the green things, right? And so once that data is in our system, it's available to DSW. We're just saying that individual customers cannot actively go and pull a data. They'll have to do that themselves. We don't make that connection for every single data source.
Yeah, but I guess because we're part of the data team, they can work to get that stuff available in the appropriate tables and whatever, and then it's just a matter of data science workbench exposing it.
Yep.
Okay.
Oh, okay, maybe last question, then.
I got to go to lunch. Okay.
Oh, okay. All right, we can talk
to us,
after.
yeah.
All right, cool. Thank you so much, everyone, for coming and listening to us. It was great. Thanks.